So today's topic will be dealing with uh, someone is asking for, yeah. So today's topic will be dealing with the live session 2, and I want to tell you guys there is one YouTube platform also is there where you can see all the recorded lecture. Last class also I have recorded and I have uploaded, but the problem is system volume issue was there. That's why voice is not audible, but you can see what are the procedure I have gone through link I have provided in my slide, which I will be sharing, and all the materials have been shared to you people through the NPTEL only. Okay. Yeah.
Okay, ma'am.
Yeah. Okay, people are asking for admit. Okay. Yep. So today is the second live class for this GIS. So today's class will be dealing. First, I want to cover what. First, I want to tell you what I have been covered in the last class, like introduction of GIS, how it has been originated, and the latitude, longitude. What is called prime meridian and equator. All these things I have covered in last class. What are the large scale, small scale things? What are the key elements in GIS? And the source commercial source softwares also I have told about in that last class previous lectures. And what is the remote sensing, how it has been collecting the data, and how the sensors are taking the data, and how remote sensing is helpful in the data collection where we can't reach as a surveyor or as a field supervisor. We can't reach, so we can look over through remotely sensors. We can look over and collect such kind of data. And GPS tells about the where on the earth surface where that thing is positioned. And its functions means GIS functions. What are the capability of GIS, how it has been used for different perspectives of engineering and medical and different perspective. And what are the application examples, how we have generated data. Last time I have gone through US geographical survey platform also to show how what are the data sources available, and Bhuvan source also, that online Indian platform where we can collect the data and we can use this data for our own analysis and output results as per our need. And OSM is the open street map where we can look over the real on the globe real structure, like Google Earth Engine I have showed, which visualize in a 3D way. OSM in a 2D plane you can look into all the feature and you can yourself generate data structure.
Data center.
And the visualization.
Visualization. Ma'am, we are seeing very low sound from your side, ma'am. Can you please try
Okay.
to increase this one?
Yeah. I will check once. Sound is not coming. It's full only. Okay. From my end, it's 100% actually.
Okay, ma'am.
Are you able to
We,
hear currently now? Somewhat?
yeah, ma'am. We are able to connect and hear, but that's only single issue that we are
Still,
receiving a very low sound. But okay, ma'am. No problem. I will manage,
sorry.
ma'am.
I'm sorry, guys.
No problem, ma'am.
Okay, I will try to speak a bit louder. Okay.
No, no, ma'am. You can speak as your
Okay,
comfort zone.
okay. So application of GIS we have seen. I have covered all these things. So data generation platform we have gone through all this UHGS, Bhuvan, OSM, Google Earth Engine. I have told in the last class, and I have visualized. I have shown you the how in Bhuvan datasets, what are the feature of Bhuvan platform and what are the things it is offering that platform. And I told you guys that QGIS software how you have to install Any of you have installed? Could you please let me know? I showed you
Yes,
in the
ma'am.
last class how to install QGIS software. You have to go through on that website. It asks you for Windows or Mac, whatever system you have. So based upon that, you can install. So, because in the next lectures, we'll be going to deal with the software in as a hands-on session. That's why I mentioned you to keep the software with you. And I showed you my QGIS software interface also. So this until there we have covered in the last class. So now today's topic is how we can visualize this real world to the digital world through GIS softwares. So GIS is the in an ideal system. We need a system to capture the remote sensing information and show us the spatial context in terms of spatial context. Like what it deals with, first it will take your information. It means store the information. Their spatial context means what, where, and when. Means from where it is on the globe, what it is, which feature we are dealing with, and when it has been created, and what are the temporally and time wise things we can see. Like I have showed you in that Bhuvan website, land use land cover map you have seen. It has been appearing for 2005 2006 year also, 15 16, like as per the year. So we can see the changes over in a barren land to how the urbanization had happened. We can see the featural and when it has been established, or what are the things are available on that like remotely also. So that is the GIS offers all this features also. Then analyze, we can analyze based upon our own interest. Like if we want to, as I told you in last class, if we want to establish any shop or any industry in a particular area, we will see first like what are the resources available. If we are going to establish any organization or industry here, are there people who are able to reach to that place? Or if like if I want to establish a normal hospital or any school, are there students or residential area where people want to send their kids to that student, to that school? So such kind of things it will be speaking about. Like I showed you in Bhuvan also, the thematic map. What we want to what we are interested in, we can go through and we can look. Anyone have in you guys, anyone have gone through on that platform which I have showed in the last class?
Yes, ma'am. I visit generally in this platform,
Huh.
Bhuvan platform, but ma'am, I have not ID that for login here,
Huh.
and I not know how to create the login ID there. So,
Okay, if
so
you
that I,
want, I can tell you, because see,
yeah,
it's
ma'am.
nothing like that. You have to go to the website.
Okay,
Are you
ma'am.
able to see my screen?
Yeah, ma'am. We are
Yeah,
able
yeah.
to see.
Okay, cool. So Bhuvan, if you type bhuvan.gov already, it will come. For
Okay,
me,
ma'am.
Bhuvan NRSC, you go here, it will ask you uh, on that platform login. I have created long back actually. So I have
Yeah, ma'am.
my wait. So here, if you see here, login option is there.
Okay, ma'am.
Then when you go here, it will ask you your info. See, I don't have, if you don't have anything, new user, you have to go to new user. You have to
Okay, okay,
give your name, you have to give your email ID, you have to give all the details, whatever it is asking. Then it will give you one link or one access to your email account where you have sent. So for what,
okay,
which organization you academic like or research, whatever you are associated with, these things as a profile, then you establish your profile. Then next time onwards, you will be able to log in here and you will be able to see all these things. What are the things they are offering?
okay, ma'am.
Okay. Yeah.
Thank you, ma'am.
Yeah. So I was telling like this analyzing information and assisting the design. Okay, sorry, I didn't do a slideshow mode. So it will be helping us, whoever is a as a GIS specialist or designer, because if we deal with such kind of things, we'll be able to create our own map, our own kind of interest, whatever we want. Like one map I showed you, that is the first map for disease I showed you, na, that one fever or some disease, I showed you that map in the last class. For pandemic, it showed all the point, what water taps are available where water is contaminated, because of that dengue or some issue was there. So
Yeah,
yeah,
ma'am.
yeah. So like
We
that,
remember.
we can analyze based upon our own, like medical people will deal with their own things, their own with engineering people will deal with in the perspective of like as a civil engineer or as a engineering design people, whatever feature you are interested to deal with, like, and mechanical engineer based upon their interest. So any industry if you want to establish, so such kind of people will deal with where customers are more, where we can get more number of resources, where the market value will be fine. If I go in such kind of area, there will be lot of customer will be coming, and lesser I have to take the charges for transportation and delivering the items and all these things. So this can be deal with these things. Like Bhuvan also showed you, when we have done that cursor thing, I will tell you, in the last class I showed you the area we have interested, there is a thematic map services, and that when we go, so here we can these are the map feature. One more things are there where we can locate our area of interest. So theme, product, program, project, no, these are the. I will suggest you guys, please make a profile and go through this platform.
Sure, ma'am. Sure, ma'am.
Yeah, yeah. So this is called satellite imagery. If you go with one more thing is there, I will show you. One is OSM. I will show you that thing in QGIS platform. That OSM, OpenStreetMap. What are the services it is providing? Here I'm not getting that. That day I showed you how to cursorize and in a circular thing. You will be able to see the video. Sorry for that audio issue, but you'll be able to see because I have explained everything in that class. So you please go through for your own localization or your own uh, problem, whatever you want to deal with, how you will be understanding those platform and how you'll be using those platform for your own interest of designing or modeling or mapping for the from the GIS softwares. Then how to develop a model, like what I told just now. And decision support system, I told you, manipulation of data collection, distribution, allocation and manipulation, analyzing and coming up on a desired output, we can deal with for a decision support system. So these things are there with the. So GIS will be helping in as a ideal system to deal with all these things what I have mentioned just now. So GIS is the data model which is the real world can only depict in GIS. Real world can be depicted through GIS. The use of model that defines the phenomena in a manner that computer system can interpret as well as perform the meaningful analysis. So when we will do hands-on, now we'll be understanding. Yeah, we are really dealing with the real world features, and we are able to predict. We are able to speak about some our own interest or things. Whatever sir is telling till now, we are going through what are the platform, what are the datas they are giving, and it depends what our interest in. Like, can you give any example? What is your interest to deal? Why you are going through the software things? So I will be able to give some example based upon your interest. Please, guys, any one of you.
Mm. Ma'am, uh, can you please show a example of use the GIS modeling in urban areas to predict anything else?
Urban areas to predict what?
Anything else, ma'am? Like home density or
Hmm.
as well we can especially ma'am, land use and land cover maps. So I want to create land use and land cover maps.
Yeah,
So how
yeah,
can I create them?
sure, sure. So I see. I showed you here itself. There is a Bhuvan thematic map services. That day I downloaded for one. See here, land use, land cover maps are there.
For urban bodies, ma'am.
For urban bodies is also there. See, land use, urban. If you guys have gone through, please go through. That day I have thoroughly explained each of these platforms and their feature, what data they are offering, what are the stat. If you go urban land use, you want urban land use. So here, which state you want?
At Uttar Pradesh, ma'am. UP.
Uttar Pradesh. Town is, so capital is
Uh,
Lucknow. I am okay. In
okay,
simply,
ma'am.
I am just taking Lucknow. So you, see, when I kept a Lucknow as a reason, what are the things it is showing? See here, you'll be able to see all. You'll just have to scroll, so it will be zoom. And for moving through, you have to click left button of your mouse, and you will be moving. You'll be able to move this thing. So here,
Okay.
what are the color feature it is saying? See, light green color is showing cropland. A bit more shade of green is showing about fallow land. Purple color is showing industrial. Like that, all the color feature. What is this telling? Red, blue color is showing river stream, canal structure. So different shades of color, speaking about different feature. So they have
Okay.
considered, and road and rails. Road is, red lines are all roads. They all are speaking. Okay, these are the road it is following, and rail is that black, a bold black color. And drainage path means river streams or drainage boundaries are this blue color lines. So you'll be able to see these feature. This is land. Or if you want to download, see here I showed you this map. You can yourself, whatever your area of interest, whatever the feature you want to, you see here, you'll be able to understand. And then point of interest here. Okay, if you want to download this thing, so just technical document you have to go. You'll be able to see the manual. So what are the maps they have created? We ourselves can able to digitize this feature through the GIS software, but for that it will go up to, I guess, 6th 7th week to delineation. What question you asked? I just showed you the direct map. What output will come?
Okay, ma'am.
So you have to understand what are the data sets are there and the things. Here so many things they have explained as the urban, what you asked, urban land use cover. And when we go to metadata, see how, what are the data, which year, which state, see region of Lucknow region, base layer is Uttar Pradesh land use map. And which kind of this NRSC ISRO thematic map services it is. And the the coverage, how much latitude and longitude it is covering, that also x and y coordinates also have provided these things. And the scale of this map is 1 in 10,000. See here, so all these things. And what, when it has been collected, so 29th August 2012. And for what feature it is, urban and infrastructure planning. So these things they have been given. You can look out if you want to import. See here, if you want to import this map into your GIS software like QGIS. So you, here if you see, web services option is there. For QGIS or ArcGIS, you have to take this link. And
Okay, ma'am.
you have to, there is one tool in QGIS. You have to go through that tool. You have to copy and paste this link there. This map, what right side you are seeing here, you'll be able to see there itself easily. So same map, and you can able to digitize, you can able to keep your own thing. If you want to see here, I'm zooming, it is taking some time. If you want to locate your own home or your own company or your own college or something, it depends upon your internet connection, so it will be just buffering. So you'll be able to zoom in QGIS software, you'll be able to digitize here itself. So these things are there. So overlay mapping, that day itself I showed you. So this thing I did not mention last time. So here you get this link and you can copy and paste this link. There is one URL, and by pasting you same map, you will be able to see in your GIS software like QGIS, which I am going to deal with in this course. And then you'll be able to digitize this map by your own hand, and you'll be able to say, see, this map you yourself have prepared, this is not downloaded from. Or You can able to see this is 2012 map. Now things have been changed. So you can see the Google satellite or Google Earth imagery on your this map, and you digitize, see new things have been established, like urban planning or industrial planning, whatever you want to do. And you'll be able to speak, see these things have not been there in 2012, and now you'll be able to see new things, how industrialization have came or urbanization have been associated by 2023. So it will be 10 year or 11 year change you'll be able to allocate or showcase. Okay, so these are
Okay,
the
ma'am.
feature you'll be able to explain here. Okay, let me go through my presentation. So that is speaking about the real world. Okay, yeah. So in GIS there are models. Models means abstraction of real world processes, phenomena, like what are the things happening, like as we gave example of urbanization and industrialization, as per the different years you can speak, because see you
ग्रीन
want.
स्केच है आपके पास? ग्रीन, ग्रीन, ग्रीन स्केच, ग्रीन स्केच,
Okay, Malay, can you
पीकेपी
please mute
बनाने के लिए
yourself?
ग्रीन, ग्रीन, ग्रीन स्केच है ना? अभी नहीं,
Okay.
हमें लगेगा, आप कर
Mr.
दीजिए।
Male, please mute your mics.
Okay, no problem. So, GIS data model is a set of instruction rules for describing or representing the real world within a computer. Like what we are going to deal with in our system, we are dealing with the global things. How the things have been changing, we'll be able to look sitting in your room, sitting in on looking in your system. So, you'll be keeping you'll be representing the real world in within a computer. So that is the GIS data model, geographical information system, as you know. So there are two type of data model, vector data model and raster data model. So I will explain the vector and raster data. It has been there in my another slide. And I'm just telling about real world model, will speak about the relationships, attributes and type classification. Like, see relationship means, see if you see the main road nearby to any industry or nearby to any hospital or school, residential area nearby to any street, or there have been paths. So relationship you'll be able to see in between the feature which you are going to digitize or allocate in your GIS model, which can be a raster model, which can be a vector model. Then in my first class I have told you there are different layers. GIS is the combination of number of layers. Like that day first slide I have showed you about the number of customers, streets, polygons like residential areas and river basin, all the layers combinedly forming a GIS map. So we'll be able to see all the layers features in our GIS software when we do hands on. Okay, so it will be telling about the relationship between different feature of the tool, as well as what attribute means. Like that day itself I told you, attribute means if there are a customer, how many number of customers are there, which place they are associated with, how distant from their location, or population density. These all number of states in a country, in the state number of district, what are the feature the district representing, how many people staying in that district, how much urbanization it is coming under rural area or it is coming under urbanized area, or how many schools are there. These kind of data sets you'll be able to see as a attribute table. Every vector data, I can say vector model having their attribute. And if you go to raster is in pixel form. So they are also speaking about their thing, but their attribute things are different. I will show you those map, because that day I have downloaded one map from Bhuvan. If you guys remember, that day I have downloaded one two tiles from Bhuvan. And then please go through my video, and you please download these things and try to see what are the things I have told in that last class. You'll be yourself able to visualize or analyze the things what I am speaking in a theoretical way. And type of classification means, see, road we are allocating as a line feature or polyline feature, any area or surface or residential building or any agriculture area we are allocating as a, okay, this much area covering by the agriculture, or this much covering as a residential area, or this is hospital area, this is industrialized area. So like that we are telling, we are giving a classification for the same feature. So I will be speaking with the images in my next slide. So fields, these are the important points for your assignment problems. Fields can be represented. There are two kind of data sets also, as a discrete data set or continuous data set. Field means an area, can be represented as continuous data sets. An object means a particular item I am talking about, particular thing, entity we am talking about. So that is, object can be in the form of points, lines, or polygon. Like I am telling now, point means allocating, okay, this is the customer or this is the shop. We are giving x and y, lat and long coordinate value, and that I'm telling, okay, this point or locating. See, if I locate in India, there are number of states. For one state, if I show, it will be like, if I select Madhya Pradesh, so it will be a point feature in that India. If we zoom, so it will be a area feature. Madhya Pradesh is coming as a area which can be represented as polygon. And into that Madhya Pradesh, number of roads are there, number of drainage lines are there, number of railways lines are there. So that can be represented as a line feature. So these, we are classifying, or we are separating. So these are the discrete data feature, discrete data model, and continuous data which wholesome, you can say, in a field based. I will show you these, all these things. So clearly defined entity with a clear boundary is called discrete data, which having, okay, discrete means not in decimal exact values. So their things are clearly defined. And continuous data can be referred as the surface data or non-discrete data, which having in between values also. So that is the difference between continuous and discrete data. So data collection, last time also I told about how the remote sensing sensors are collecting data remotely and giving us to analyze in GIS tools. So data collection typically accounts for half of the total cost of the GIS project. In general, because collection of data itself, for any researcher, for any academician, for any person who is dealing with GIS software, first you need, see, that day you told na, Bhuvan platform and all these things, dem file processing and everything is the next step. First you have to collect the data. But GIS and this remote sensing made these things very easier for, as a student or as a researcher, for us. So will we need not to go to the website. We can be, see, data can be as a primary form where surveyor are going at the field and collecting the data, or data can be in form of secondary data set. Sir have discussed in the class that primary data we can rely, because we are going and collecting from the defined sources. But secondary data we are getting from, you can say, from sensors, or we are getting from any organization, governmental organization also having that manual, that data sets, and we are incorporating in our, but it having lot of errors. So mostly first choice is our primary data set. But as students or researcher, we are not able to go to that sites and these things easily in the remote located areas. So what we are going, we are analyzing the secondary data sets, and we are moving for our analysis, and somewhat correction we are also incorporating into this thing. So data collection process involves, first we plan like what we want, how we will be going to reach or collect this data set, and then preparation, what we have planned, how we'll be going to tackle this are the our what to say, major points. Okay, digitizing means, then, okay, I got this location values, I got this rail feature length, and I got this aerial feature, like if you see any industry, or if you see any agriculture area, if you see any residential area, such kind of features. So now we have to digitize through models. Which model? Vector data model or raster data model. And then we can edit if we need to edit, like as I showed you that Bhuvan land use land cover map is there, we can incorporate in our GIS software, and we can add, okay, that is 2012 map, and now I am digitizing some more feature which I have seen from Google satellite imagery or any remote sensing data sources. Now currently in 2023, what is the status? So now we can digitize or we can edit our own new building or new infrastructure, and we can say, see, now that much urbanization have happened. From this is the change, decadal change. 10-year change or 11-year change is a decadal change. And then we evaluate, okay, now we can speak how urbanization affected this area, or how this how this industry have been developed from the initial stage to the now, what is the current situation. So like that we can evaluate our own inferences from that maps or from that digitized image. So data collection also be referred as data acquisition. Acquisition means we are taking this data, we are collecting this data, and all this thing. Same kind of synonym you can say. But digitization having error because it is manually happening. Some people uses scanners also nowadays, but in real world problem we have to digitize by hand. But if you digitize one building by hand, it will take a lot of time. One building, you have thousands of building in one area. If you take a map, any square tile also, if you take, there are number of buildings, correct? Because it has been taken from a sensor, from satellite imagery. Then number of building you will be sitting and digitizing one by one manual, it will take a lot of time. That's why we are using scanner kind of things, where, but scanner, we can't rely on scanner also, we need both. Like few things we can digitize by hand and then proceed by scanner. Okay, then now scanner can sense, okay, these things are uh, like this feature is represented as polygon, this feature represented as a polyline or line, this feature represented as a point feature. So now I have to move with this kind of information, and I give to output for the number of things what have been allocated in that particular map. So like that. But if we do manual digitization, it is having undershooting means, like if I created, sir have showed that slides for undershooting, overshooting, dangling, knots, switchbox means switchbacks. It means, see, undershooting means if we are digitizing a polygon, and what happened, we are not able to complete that polygon, it has been remained unclosed. Understood? So it will be undershooting. It is not covered. If it crossed, if both the line have been crossed, it will be overshooting. I'll show you this examples in my GIS uh, tool, but I want you guys also to do or go through, so it will, you will be able to understand what theoretically sir is covering and I am also covering. So not also like when you create one polygon or line and you created one extra inter interface and vertex and switchbacks. So these things are errors in digitizing procedure. Digitizing, first you have to georeference one map, then you will be able to digitize. Georeferencing can be done earlier. Georeferencing can be done like you take a system, sir have showed you, you guys have gone through that video I guess. So in that, sir have shown you earlier how we don't have GIS software, how manually with that image, keeping 2 3 points on the screen or on the tablet on the system, we are manually pointing 4 3 points, and then we are manually making coordinates and coming up. But now when GIS came, now we are georeferencing that feature, and we'll be able to move anywhere on that map. It will be accessing all the coordinates, and that coordinate system covering I'll be covering, because globe, see, globe is a 3D structure, will be coming in 2D maps. So how will be coming that, that has some system like coordinate system. So these kind of things are there, which I will be going to tell in my next week class. So then you'll understand, okay, this 3D map, how it has been converted in 2D map. So number of coordinate system have been there. To understand this thing, after allocating the coordinate system, you have to geoposition or georeference for your map. After georeferencing only, you will be able to digitize your feature, what feature you are interested in the particular map. So now one more thing are there: nominal scale, ratio scale, ordinal scale, interval scale. See, nominal scale like number of students, like numerically or numbers we are giving, like okay, 1 2 3 4 we are assigned this feature, like that. Ratio feature like sir have shown how marks scored by a student out of out of, like in terms of ratio, out of this much this student got 20, 200 marks, this is student got 400 or 420 kind of. Ordinal means we are ranking in order of student in that exam. Or interval scale means performing the rating of student on a scale of 0 to 10, kind of as we got CGPAs. So that is not associated as a ordinal. So you will see the difference between nominal, ratio, ordinal and interval scales. So that's just for your kind information. And first let me tell you, that is my in another slide. So let me tell you about the data, raster and vector data sets. So what are the data structures and the formats of data? GIS is a geographical information system. As a concept, they are similar, like what I was telling. So, a concept, they are similar to an overhead projector. If we see a projector, see, with a series of transparency laid upon it. Transparency means they all layers, if you see, first layer is infrastructure, second layer is the school, showing the school, blue colors points, and red color points is showing water abstraction points. Land use feature can be allocated as a polygon feature. See, different colors are showing in land use and groundwater vulnerability. So all are transparent and they are lying overlay upon one another. And they will speak about number of feature on a real world. So computerized system for the storage, retrieval, manipulation, analysis and display of geographical reference data. Geographically reference data. How we do georeferencing? I will show you what georeferencing means. We are allocating latitude and longitude on the map so that we'll be able to move over the map anywhere. If we allocate three, minimum 4 point we have to locate in that map. That I will tell you manually sir has taught in class, but how to deal with these things practically by your own, for your own map, for your own interested area, I'll be able to tell you in my next coming week classes. However, the term is commonly applied to any manipulation of geographical information in digital form. So there are four kind of spatial element, like as I have told you: points, line, area, surface volume. Point is no dimension, a point having latitude and longitude, as I told. So no dimension, like any house address, post office address, any locality, like I have told you in Indian map, one state. Then line, one dimensional feature having only length, है ना? So road, stream, these are coming as a line feature. Aerial feature, 2D, which is having an aerial perspective, like parcel, field, or surface volume like 3D, which is x and y is also there plus z is there, means kind of mountain contours, sand dunes, or any valley, such kind of structure. So the data structure is in the form of georeference data are represented or stored in a computer. So see, here also I am speaking same only. The layers, like see the terrain elevation, see the road maps, soil types. These are all layers, different layers. And data can be represented as a raster format and as a vector format. So type of data models, like first I am telling about the raster data model. The terrain is subdivided into number of parcel or cells, grid cells. Each grid cell must contain a value. If you see here, you'll be able to look the same, but each grid having different values. This value can be integer or a character. Means it can be a numerical value or any ABCD kind of things, character or any name or something. Like if you go through Indian country, number of states are there. So like Uttar Pradesh, Madhya Pradesh, you know, such kind of things are there. Or if you look on uh, number of population density and all this thing that having a numerical values, so such kind of feature it is covering. So all raster having some values. See here, cell number, cell values, code list. So these things, grid values indicate quality and characteristic of the spatial object or phenomena. All grid having a cell number. This grids having 1 2 3 all are cells. If you see, the cells having cell number and having some value. Like see here, number 2 is representing road, number 3 is representing, that is the codal value. So it will show, if you see the first image, 0 0 0, how it is lying, and 2 how it is covering as a road. So it will be telling you, okay, this number is associated or allocating the road features or building features. So these things are there. Generate a structure for a grid. Like if you see any raster data having a grid format or grid extent, where one one pixel is called as a resolution. Like if we take picture in our cell phone, we used to speak, okay, my camera feature is this much resolution. And so if you see, it is covering a row and column also. So grid is the number of rows and columns. It is having some extent, means having some resolution values. And then each individual grid or single is called grid cell. And each grid cell having a value which is allocating a feature, as I told in my previous slide. So linear dimension for each cell define the spatial resolution of the data. In raster database, value pertaining to different characteristics at the same cell location are stored. So see, raster data coming in different format. You no need to confuse into this. First, raster can be a JPG, means image. Raster can be a TIFF format, GeoTIFF format, PNG, BMP, PCX. This all are the formats of raster dataset, image format. And data can be compressed for reduction of, see, when you collect for 1 year one satellite imagery for one grid cell, and similarly for another tile or another grid values, you will be downloading for 1 year. There are number of grid, number of raster resolution image, and for one image it will be having some kb value or mb storage value. So it will take lot of, for 1 year if you collect, it will take lot of storage or memory to keep. So data compression also can be done in GIS, so that you'll be able to keep for number of for compressed same data set in a compressed format. So that is also can be done in raster dataset. Re- Information storing as per the run length, because if you want to deal with your urbanization or industrialization, you need you need 10-year data or 5-year data. So how you will store, how you will be compress the data in terms of all are in image format or raster data format. So this can be done like 4 by 4 raster matrix in ASCII file. Most of the codes in GIS or this kind of software are in coding language like Python. Mostly are in Python or are ASCII code. So like that, they are having their encoding strings. And uh, you can say uh, in terms of loop. So like that, it store the information in that matrix form, and it will show you imagery of that codes to your GIS software. I will show you how the Python code you'll be able to see in your GIS. When you do any manipulation of image, you'll be able to see those things. Are you able to hear me? My voice is audible to you?
Yeah, ma'am, is perfectly audible, ma'am.
Okay, okay. So sources of raster data. See, as I told you, there are number of sources that last class I showed: USGS, LIDAR, multi-beam sonar, Landsat, Spot. So these all are source. Links are already provided. You can go through all the links or digital orthophotos. Like in general, if you go to any organization things, they will give you digital orthophotos. This also satellite imagery you'll be able to download by your own side. Digital elevation model, these things you'll be able to download from the open source data. So if I tell how the remote sensing data is well known example of raster data. See, if you see here, there is one image of discrete data sets for raster itself and continuous data set. So continuous data, you in raster format of DM, if you see this yellow and red image, this is continuous data. These cells are not discrete, not having defined values. So you'll be able to see the blurred kind of or gradient kind of color formation. And if you see this discrete raster land use feature, one color speaking about one feature, another color speaking about another feature. Like here it has mentioned 10, 10 for blue, 14 for pink, 13 for your orange or light cream color. So these things in discrete things are defined, in continuous things are in interval, covering some decimal also. So it will be this kind of. So in discrete you'll be able to see the road features, the first image if you see it down, you'll be able to see the road feature. And in continuous you'll define through this continuous raster image. Here you can't see, but if you go through this image format, you'll be able to see grayscale these things. You'll be able to see the feature, how this road line is going, and how this residential buildings are there, how this agriculture boundaries are there. So these things you'll be able to look into the raster. So I will show you one raster image which that day I have downloaded that dem file. So you'll be able to see all the information. Here I just showed you that screenshot of that raster image format, how many columns and rows, because raster format deals with the columns and rows. As I showed you, it is having cell, number of cells, grid cells, and it is having number of rows. So here it is telling, see, 410 columns, 564 rows, number of bands, one band, one image if you put, it will be one band only. Grayscale, cell value, we can change these things as per the remote sensing that product, that data collection. This all is not dealt by GIS, this will be dealt by the sensor, like remotely sense data. So that is another thing that is comes under data collection or data acquisition. But analyzing part comes under manipulation, analyzing, editing, digitizing, georeferencing, it comes under GIS software part. And then this information it will give. So raster property. So when we go from raster to vector, we'll be speaking like, we'll be telling about we are going to do vectorization. And when we go from vector to raster, we'll be speaking like, okay, we are going to do vector to rasterization. So I will show you, there are menu or there are options where you can change raster to vector or vector to raster. Sir have showed you very good map feature into the class lecture, like how the raster converting to a vector. If you see here, this gray color 222, if you see, all cells are covering and making one road line. So if you convert into raster, it will come as a line or polygon. In this rectangular grid, it is a polygon feature which will be showing you as a gray color, and green color is covering as your agriculture area or your cropland, and that blue color is covering as your water body structure. So if you see in raster format, it will be appearing as a cell, and if you see vector format, it mostly appearing as a polygon and lines feature. Or if something is there as points also, you'll be able to see. So raster and vector model here, how in the real world it will be. See here, trains, sorry, the road lines is appearing here. How, and then how the trees as a point feature have been appearing here, how the buildings have been appearing here. So all they have assigned. See, road line R, everything they have assigned. For this office or for this hospital, they have assigned H, it is there, but this is the open land. And forest also FF they have assigned. And then house they have mentioned here. So like that point feature, and like that raster grid cell they have assigned. So these are the raster grid. And similarly, if you see for road, they have assigned this polygon. For building, they assign points because there are only two buildings. For number of trees, they have assigned one polygon. Okay, this much area covered by this greeneries or this plant or trees. And see here for forest also they have assigned a circular polygon. So like that. So how the image converted, real world image converted to a raster grid or to a vector grid, it is showing the raster and vector data models. And the point features also, 0 is telling there is no values, means no data, I'm not interested in these kind of data set. But 1 is telling okay, there is some value and I'm interested to get this value. So if you see this raster, it is there, well raster is there is a grid 10 by 10 grid cell is a raster format, but three wells are there. So if you see in vector format, there are 3 points are given. The advantage of raster data is raster structure is very simple. You need not to tell about each attribute feature, because if you go to vector dataset, I will next time going to speak about vector only, but it is a bit you can say complex, because each feature you have to assign, each building you have to locate. So these things are there, but raster, if you take one image, if you know this many numbers of rows and columns are there, this number is speaking about this, as I showed you in my slide, 23 is speaking about roads. So all 23 are roads in the grid value. So like that, it is a simple, it need not to deal with mostly complexity in attribute tables. But use of cheap technology also, because if you have jpg format, raster is jpg tiff format mostly. So cheap quality, you have to just click a picture, you import that picture, you georeference that, you digitize, you start digitizing, easy and cheap technology. But for raster, you have to go through any organization, you have to collect the database, you have to allocate each point, you have to allocate each line for the particular length, for the particular area feature. So it will be a tedious task. So raster is flexible and easy to combine with GIS dataset. Raster format, if you have, you'll be able to work like for urbanization also. For any, if you see land use land cover map also given by that NRSC ISRO Bhuvan software, they are having the image format. Image format that when the layer you import now, you'll be able to see all feature, all layers. Some are points also. Points line means vector also, because real world cannot be explained by raster only or by vector only, because everything is not in grid cells also. Some feature you have to allocate with vector. So both the combination have been used to represent the real world, raster and vector. So ease of the data collection, as I told, you need a sensor or you need a camera or capture device to collect this information. Ease of data processing, if you go to the GIS software, I will be showing you how easily, just clicking, you'll be able to see the processing, or you'll be able to see the changes in map. But for vector, you have to do some more manipulations are there, editing a cell or changing code of the cell. So it will be easy, as I told, this softwares are dealing with your python coding and all this thing. So that is easy there. And modeling also, you can incorporate your own feature, as I told you, if you want to see the changes between past datasets or now what you have manipulated. So it can be representing, it can be a model for a real world thing. So you made your own model, you can say like that, your own imagery, your own map, or you will be inferring some values, some reference from that map. You'll be telling okay, this changes have occurred as per the climate, as per the locality, as per the urbanization, as per the demand. So these things you'll be able to speak, you'll be able to make your own report from all this information. So raster advantages, like, see, it is simple data structure, as I told, easy analysis. See here, simple data structure means, as I told, 23 is telling about roads. So here 3 3 3 3 matching 3. 3 is speaking about one feature. 1 is speaking about one feature. 2 is speaking about one feature. Simple to understand. Each grid having a representing one value, which is telling about one feature. Easy analysis means you'll be able to sum 3 4 layer all together, you'll be able to work There are raster calculator, one option is there in the menu bar, raster menu bar. So you need not to sit and you need not to calculate. For vector you have to calculate, you need some there is one in attribute table, I will show you that how the calculation are going to be done for raster dataset and vector dataset. So for raster, only one option, you have two three maps all together, you have to plus, you have to minus, or you have to divide one land use land cover feature from that earlier feature. You don't need to, you want to subtract one layer from another layer, you'll be able to deal with all this thing easily. But for vector, for each component you have to do manually one by one. That's why mostly easiest way of dealing with all these things, you should have raster data model for analyzing your feature. So low tech per platform. For raster you need not you need not to go through the organization, you need not to make your excel files, each calculation, your these things. Like if you have the imagery, if you have the software, just go on, you will be able to deal with the problem by your own self. Very low things it demand. And remote sensing, but you should have the skill to analyze the raster, because raster is having lot of information as compared to vector. So remote sensing data, because if you see this maps, this raster image, you'll be able to see same map as road feature and agriculture land and how the industrial or residential area it is showing. So this is remote sensing data which calls as a raster dataset. And modeling, like see, we have slope, we have soil, as I told, the calculation or themes can be added or can be multiplied or can be, like any equation is there. If you need for erosion potential in any particular land, agriculture land, okay, this much rainfall is happening, and now because of this rainfall soil is eroding and somewhere it is getting deposited. So how this changes is happening, there is one equation for erosion calculation. So if you have modeling comes, like you have different layers, you are overlaying, you are using some manipulation or statistics from that software, and you'll be able to come up with your own results or output from the generalized equation. And you'll be going to say, okay, this is the generalized equation I have used and I got this map, and from this map I am going to tell, okay, this much changes have been occurred if we have this input. Like if the slope is from 0 to 10%, 2 to 5%, like that 0 to 2, 2 to 5, 5 to 10, changing like this. So soil profile is like this, now erosion is happening in the particular area is this much amount. So this inference or modeling can be done easily if you have raster dataset. So these are the advantage of having raster data. So disadvantage of raster data means sometimes data handling, because raster is having good number of information, but for handling you need good memory or hard drive or storage device. Less compact data structure means you have to compress. As I told earlier also, you have to compress the data because it is having uh, you make the things in a compact manner, you have to compress this heavy volume data. Low cartography quality, see sometimes you'll be getting good maps, sometimes it got blurred because of cloud, because all the raster images mostly are satellite image or sensor based image or captured image, that all are having their own quality. See, SRTM dem we are collecting some satellites or Bhuvan, it is giving 30-meter dem, some are giving 90-meter also, means that map has been collected from the aerial photography from 90-meter scale, and from 30-meter spatial resolution. So I will show you one map which is showing this all this changes. If you have map of 5-meter, 30-meter, as I showed you in Bhuvan also, see here in Bhuvan also you'll be, where it went, I told you na that they Bhuvan having four kind of uh, resolution. Like if you see Indian level resolution from the world, which is 23, the day I told you, Some is 23.5 meter, some first is 50 meter, then 23.5 meter, then 5.8 meter, then now 2.5 meter also, based upon, see, from the world coming to our country, country to state, state to district, district to mandal. So it is, if we go to our satellite image, we need satellite. Okay, it is asking for login. Here I'm not able to do. I will show you in QGIS software. Not here. It is not happening.
Okay, ma'am. Okay, ma'am.
Yeah. So that is low cartographic quality, means the low image quality. It, how good resolution you are having, you'll be able to see the detailed map in a proper manner. So it depends upon quality of your sensor also, and quality of distance of data have been taken. That is also like 30 meter, 90 meter, 5 meter. So that will show you how much detail it is covering in that image. Inaccuracy also have been associated with the raster data structures or models, that is controlled by cell size. Increase in accuracy need smaller cell size. See, accuracy can be, if we have a smaller cell size, it will increase. See, if you have good pixel value camera, it will be like having, if you do go zoom, it will be showing a rectangular grid, smallest value, but it is having good, you can say, memory, means uh, good storage volume. It needs increased data volume. It is more uh, kb or mb, you can say, in comparison to if a low quality data is there, which is having uh, lesser volume of the data, raster data. So data volume also play a big role in raster data. It is a disadvantage. And displaying also, like raster data to display, you need a for clear picturization or for clear understanding of any imagery, you need a proper display platform also for raster data, or else it won't load. It depends. Sometimes some softwares are supporting some files and some are not. So display is also one of the issue with this data sets, because vector data can be made or can be generalized or can be imported in any of the software, but for raster depends upon the version, quality, software, so many, or sensor, so many things are coming in picture. Storage space increases dramatically with the precision of raster resolution. As I told, low resolution or high resolution. If you see here, 8 by 7 grid, one cell having this much area. If you see here, 33 by 30 grid, one cell covering 90,000 kilometer square area. So, which will be a heavier? Heavier means which will be having more volume. High resolution imagery. If you see, the grids also more in the high resolution, more clear, and more details you will be able to see. So here, if you see here, for two number, how just the map has been formed, the polygon in the raster, how many grids are coming, here you will see the detailed proper way. So these are the difference between low and high resolution raster. Disadvantage of spatial inaccuracy. See, there may be if you make a map, river network in vector, you'll be able to take a one polyline or line feature, you'll be able to make a river stream, or you'll be able to make a line feature. But for raster, you have to select the grids. Okay, these many grids are coming in this road feature, so I'll be selecting. So that is also one of the issue of the raster. Same, similarly, all the other things I have been given. And then vector data model, spatial objects are identified and represented by the mean of coordinates. Like as I told, point feature are as a coordinate by using one or more pair of coordinate. If we go for line feature, like so many numbers of point combining, finding what combinedly forming what line feature only. Number of points, if we join one point to another, it will be forming lines only. by using one or more pair of coordinates. It is represented by one or of the three basic geographical elements: point, line, and polygon. So three things are there in vector data model. See here, as I showed you, that red color area is showing building, the blue is covering all our polygon here. If you see line feature, is it is not there because road also covered as a polygon. It has been shown in a boundary, that's why I am telling as a polygon here. And then see, at least three intersecting straight lines are required to create one polygon. See, 2 points will be covering a line, and 3 will, if we take, then only will be able to create one area or polygon feature. In a vector data model, vertex can be identified as a intermediate points. Vertex, like when we create a line, so first and last will be the edges. In between intermediate points are called vertices, like that. So it is a intermediate points. So in a vector, in the vector world, points is the basic building, like building block form, which all spatial entities. Here you can see how the points and coordinates value have been assigned. And for all the vector, you'll be able to see the attribute. Attribute means, see here, in geometry, vector is talking about point, line, and polygon. Point, ID number 1, attribute telling about A and B, both the attribute. Coordinate value 4 and 3, one single point, like that. It may be talking about some, okay, this is this building kind of feature. And for line feature, there is one ID, there is one attribute, or there is number of coordinate, because if you see, for line, the points are joining. So coordinates, how many coordinates it is covering, here you can see the how my, where I am locating from my pointer, you can see. And then for polygon, if you see how many coordinates have been assigned, and the id means one value have been given to this vector feature, that is the ID number. And it is telling about the attribute table. I will show you the vector attribute table. And raster information, raster data is not having attribute table, it is having information, their layers, symbology, and this thing. But vector having attribute means each feature speaking, as I told, if you have to, if you want to digitize in a map, there are so many buildings, so many residential buildings, so many industrial buildings, so many commercial buildings, so many hospital, so many other features are also there. So if you sit and digitize by hand one by one for each feature, so it will take lot of time, or number of polygons will be you have to make. Digitization means you want to create your own feature, that is called digitization. I'll be covering when I cover georeferencing. After that, after georeferencing only digitization is coming in picture. After digitization, how you'll be going to edit those feature which you are interested in, and how you will be going to prepare your own map, and you compare from the real world thing. So see what modeling is mimicking the real world. So we are using our own tools, and we are making our own map, and we are saying this is the model of our real world thing. And now I am getting this much information, and I'll be able to speak about it. Like that, as I told, you'll be able to make your own report for your own interest. So vector approach, a line consists of two or more coordinate point, as I told. Again, storing the attribute for the lines in a separate file. If you see here, point is one value, line is, here it has showed these features, and I am just telling about the point, line, and polygon. The best way to define a road network is via a line. Road network can be defined by line feature mostly, or drainage networks also. Vector data model can be used to mark exact boundary, because as I have showed you also, in raster you have to select grids, how many grids are coming into this line. But vector is a kind of discrete model. Vector selective is a defined value, so it is a kind of discrete model. So vector model can be used to mark exact boundary of the river body. And then see, as a raster having image format, TIFF format, and other BMP, so many formats. Similarly, vector formats are also there, like geographical base file, Tigger, dig, digital line graph, data exchange format, arcinfo coverage, arcinfo shapefile. So mostly vectors, we generally deal is called shp. Dot shp means shapefile. So I will create one vector feature and I will show you how it is showing as a shapefile. So advantage of vector data, it, as I told, advantage of raster data, vector data is more compact. Compact means, so see, line feature, we are allocating one point. It is not like having volume means not heavy files, it has very less volume of file. Cartographic quality is high because it is defined feature. It is a defined vector data model, is very defined and sophisticated attribute handling. But the problem with the vector data is having attribute table. You have to locate each line, each point, each polygon. You have to tell each feature characteristics. So handling this itself is a big task. So mostly people used to deal with the raster data. They work on raster data. Representation is also one issue. If you have to take a lot of information which in one image of raster you'll be getting. For vector, handling so many information in a vector data sets and representing is an issue. Resolution is also a constraint because uh, resolution is good here actually. Yeah, representation, sorry about that, representation in vector for a detailed way because it is a defined structure, it is good. And resolution is also fine because we are allocating each feature nicely, not in a grid format. And storage space is also okay because I told you, as a compact data structure, it is having lesser volume of file. And topographical relationship also, you'll be able to see how the changes have been occurring, as I showed you one map of 10, 14, 13 earlier just now in one image, where all this things have been, it will be telling about that map I showed you, river, building and road map. So you'll be able to see the relationship between the features. See here, vector advantages, high resolution map analog, how it is showing. If you see this here, Africa, if you zoom in vector, you'll be you'll be able to see the scale independent resolution. Vector data is not, see in raster, if you zoom, pixel will go, resolution will go, but for vector, no problem with the scale. This thing, whatever scale you give, you'll be getting the information correctly. No resolution problem is there because it is not dealing with the grids. And node vertex storage, like vector display, here it is showing shape shape point storage. It's better I will show you these things in a application, that QGIS application, so you'll be able to understand these things. And theoretically sir might have explained already. So here you can see this understanding way, how the vector data is talking about feature on the land surface and how the raster data, because raster you have to confuse with the group, because raster will tell in terms of grid cell. But if you identify feature in vector, it will be easier to deal with. That's why real world problems have been mostly deal with the both of the feature, because some features vector data model easily, or like less compact structure and resolution problems are also not there as compared to raster. So some feature is good to represent as a vector data model, and some feature is good to represent as a raster data model. Topology also, you can see reverse streams how we are showing as a vector data. But few disadvantages are also there with the vector data, like complex data model, difficult to overlay process, because as I have showed you, theme 1, theme 2, how soil map, slope map, these things are able to calculate or able to uh, overlay one layer over another is very easy in terms of raster. But these things are difficult in terms of vector data model. Expensive data collection, because you have to get the database or the all the information, and you have to collect this in your excel, and then you have to import these things, or you have to allocate each point, line, and polygon feature into your GIS software. Then you will be able to process this. Expensive data collection, as I told, use of expensive technology and system. Obviously you have to go, you need, like, there you captured the image, you got this DM, you downloaded sitting on your system, you'll be able to do. But for technical understanding, the the understanding the concept of database management system, how the data have been taken, what are the multiplication or statistics have been applied, what are the topological feature for the vector model. So it is difficult to understand. No one, like, for you, or if you are not aware of all the things who have made these things, you need that skills to understand. If not, you are not able to deal with the vector data model as easier as in raster data model. So disadvantages: complex data structure, handling attribute table itself is a big task, demanding teaching. You need a skills, as I told, you need a skill to understand this vector data model. Technical skill is required, and introductory training, or else you go through any workshop, training sessions, these things, how we are allocating vector, raster, and this all sorry, this line, points, and polygons. So these things are there today's. Now I was just thinking, like, okay, 20 minutes are still there. I want to open my QGIS, and I want to show you vector raster. So I have installed, as I told you last time also, how you have to install the QGIS software. You have to go through just the Google and QGIS download. You do, it will show you that QGIS. So download QGIS 3.28. You have to, will be able to download as per your system also. If you have Mac, other system, if you have Windows, you please click on that. You got one file there, you have to install that file in your system. You'll be able to open that QGIS software. I am opening my QGIS version. I feel it will be opening. Yeah. Okay, by the time it is opening, let me tell you about terrain model. Terrain model, see, few models. Terrain model is speaking about z dimension, x and y coordinate covering in surface model, but third dimension have been covered in terrain model. Terrain model is of two type. One is distal surface model, another is distal terrain model. As sir have told you, when a z value is a single value, it is not taking multiple value. That is 2.5 dimension terrain model. When multi-valued surfaces are there, it is having three-dimensional terrain model. So if you see here, distal terrain model, this blue color is showing distal terrain model, means it is only telling about the elevation over the earth surface. But if you see the red color feature, you'll be able to look into this, what are the surface feature are also there. Means, see, there is a land surface from mean sea level, it is having this much elevation for all over the land surface. Like, this is called topological, uh, or you can say elevation value. But on the land surface you have one overhead tank, or one building, or from to your terrace, or from any tree or forest is there. So how much elevation it is taking from mean sea level, it is, the surface feature also can be considered in your distal surface model. So that's what the difference between these two terrain model. So data structure I have given, I will provide that another slide also, which I have just now told. So both will be there. So for today's class, and from last class I have shared those things in that YouTube channel, you please go through that. And my email ID is also there. So okay, let me check. QGIS open? No, it doesn't open. Okay. So okay, how many of you installed QGIS till now?
Ma'am, I installed QGIS today,
Okay.
but not start working yet on this.
See, that day uh, I have downloaded two files that day from, okay, on the desktop I'm keeping one folder. Two file I have downloaded from Bhuvan, that is style of SRTM dem. So that is the raster data. Okay. So I will tell you, I will show you that map also. So this two tile I'm importing. When you download any tile from any of your online sources, you will getting zip file. Zip file, you have to just right click. You have to just extract the zip file. I'm extracting that file. Okay, it came. So I have extracted two Landsat file. If I open, see here images, JPG images formats are there. If I simply open and see, we are not able to visualize this properly. But if I open in QGIS, I will show you how this is appearing. This is Landsat. This is Bhuvan imagery. I feel maybe I have extracted both same only. Okay, let me check. That is for 8th November. That is for 28th. Okay, November 8. That is okay. 2011. Okay, fine. So this is my QGIS platform. If you open in your QGIS, you'll be able to see these are the project, edit, view, layer, setting, plugin, vector, raster. So where we'll be going to deal with vector or raster data model. Web, web, where we'll be going to access our OpenStreetMap, which I told OSM, or as I told, I will show you in our QGIS platform. And this all things I have installed and I have kept it. That's why it is appearing with number of option. When you download, you may not be able to get all these things. You have to get the settings also from Google links, and then mesh, then SCP is I have just now. If you need any of this tool, you have to right click over here. You have to right click anywhere in the in this toolbar option, menu bar option, right click. You'll be able to see some more panels and toolboxes if you are willing to work on. So SCP is telling about semi automatic classification plugin. So like that, vector toolbar, web toolbar, these things are there. Here, this is the new project. Anything if you are going to work with QGIS software, you'll be going to save it as a project. You'll be working on particular layer, format, any data format. You'll be going to save it as a project. So save as wherever you want to save. I will be clicking save as. So I have made one directory on the desktop, the datasets. Okay, I'll be making as my output value. I made one file for this. So here I am just naming as a QGIS first project one, the class. I saved. See here it's saved as a named as a project one QGIS. And this is processing toolbar. See, if you don't know from where I will get this tool to work upon my model or my what data you have, what layer you have imported. So don't search here. Don't search here. You may not get. Better you search here. Processing toolbox. So here processing toolbox. If you see here one vector, if you go to vector, you want to do any analysis. See lines to polygon. So if you are not able to get from all these things, polygon to lines. So here you just search lines to polygon. It will show lines to polygon. It will show you lines to polygon, same option. So it will help you in this way to search easily, or to get the tool, or get the option easily. This is processing toolbox. This is browser. Browser means to, if you want to incorporate any, it will show you where, which directory you are like project home. This all are my directories. This all are xyz tile. See these tiles I have incorporated. I've got some links from online open sources, and I'll be able to incorporate this Google Maps, Google Roads, Google Satellite. It means it will be covering whole globe. Wherever I want to represent anything or any feature, I'll be able to. This all links I have downloaded. I will tell you how to download that. And the road satellite hybrid, the terrain model, open street map. So these things are there. You also able to access. I will tell you how to access this. I'm just telling you the interface, this processing toolbox. That day I'm not able to tell you, that's why I'm telling. So browser and layers here. Here the main thing, it is the important option here, is the layers, what you are going to work upon. So till now I did not work on any of the things, that's why it is showing no layers. But if I incorporate something, it will show you my layer. And here, how to add data here. See, this is, if you want, uh, you can go this option. There is this option. If you click the cursor, it will show you data source manager, open data source manager. So from here only you will be going to incorporate any of your data set. So, see, if you have any vector data, raster data means image, JPG, TIFF file, vector data means shape files. So it will show you when you select wherever directory you have downloaded from your Bhuvan, or from any sources, raster data, vector data. See, for Indian region, as I have got some India map or shape files from Ziva GIS is one platform is there. So I will tell you from there you will get some administrative map, road maps, river stream maps, and few more features they have given. So whatever your need, you will be able to get these things from this open source data, and you import those layer into your this QGIS platform. And then raster layer, then mesh also. Delimited means your, if you have Excel sheet, csv file, or if you have any other data file, MS Office and these things. Excel mostly we are going to deal, comma delimited files. So you'll be able to import those also, you'll be able to see, but you have to convert those file into your vector or raster. Then only you'll be able to work as a shape file. Then only you'll be able to work. Like, if we I have uh, what will I say, if I have buildings, 1 2 3 4 10 15 buildings I have, but all buildings having their own point, or their own lat long, their own x and y value. So what I will do, I will keep latitude, longitude, and for building 1, latitude, longitude for building 2, like that I will mention. And I will make one Excel sheet, and I will import that Excel sheet of that building locations here. How you will import, when you select whatever data you have. See, mesh data set, if I have, I don't have. So file name, it will ask you, go here, go this option. See here, it will ask you browse. So go here, wherever you have kept your data, you brought it, and then you say, it will ask you add. When you select one data, it will ask you add. So it will add that layer. And then geo packages are also there, like as geo package I told you, this Google Map, Google Satellite, this all are geo package only. Connection, you have to create connection, you have to give that package. And then spatial lights, it depends as much you used to explore. This platform is very good, as I told, open source, for students, for researcher, for for working on this GIS. Best source is QGIS software. You can create your own map. You first build your own model, you create, then you create your own map. You can infer from those map, that attribute table, that raster information. You can create lot of, you can get lot of information from this tool. And but you have to explore this feature, you should be knowing, then only you'll be handy to work upon the software. So okay, I want to first today, as I have told you, I want to incorporate some open street map. So how I have got this map? Uh, we have to just go to Google, select Google satellite in QGIS or open map services in QGIS. So it will ask, it will tell you how to add satellite imagery or Google Maps to QGIS. So when you go through that, you'll be able to get some links. See here, some URLs are there for Google Map, Google Satellite, Google Hybrid Satellite, Google Satellite Hybrid, Google Terrain, Google Roads. It all over the globe. It will show all the feature as we are last time we have seen in Google Earth Engine. Similarly, you'll be able to see your QGIS. Because I am importing this map, why I am importing this map in QGIS? So that I will be able to see all the feature over the globe in my map itself. I need not to go and look over Google platform and all this thing. I'll be able to incorporate those platform into my QGIS and make my own model through this raster and data format. So that will be very helpful thing if you connect this URL. Are you able to get? Hello.
Yeah, ma'am, I'm here.
So I'm just telling like Google Map Tide. These are the services links have been provided. You just have to go Google search this thing, Google Map, Google Satellite in QGIS. Then here one option will come, how to add Google Satellite imagery in QGIS. You will get
Yeah.
links, okay, URLs. Then what you have to do, go to your QGIS, go to XYZ tiles. That browser option is there. Select this XYZ tiles. Sorry, it's not coming here. Here you have to go by, just a minute, guys.
Sure, ma'am.
Yeah, yeah. Right click over here, new connection. So right click over QGIS. You have to check this thing. Sometimes I may also be working. I may forget because a lot of options are there. So new connections. Then it will ask you XYZ connection. Which connection you want to create. So what I did, I am going to create Google satellite name. Okay. So Google satellite URL I'm going to import here. So when I name, I have to name this. Okay, I'm going to import Google satellite, and from that that open sources I got Google satellite link, that URL. What I do, I will copy this. See here, I copied this and I went to this URL option. When I went, I just paste it and I will do okay. So if you click here, see two times. So I already have this. So it showed me here Google satellite. See, if I do double click over that, see here it is loading. What it came? It came the satellite imagery over the globe. See,
Yeah, ma'am.
and in layer, see here in layer, what I'm working with, this layer. So this layer will come. If you zoom in, just scroll it. If you zoom in, you'll be able to see. See, this is the Google satellite imagery of India. It will load as much clear it will go. It will load more and more. Okay.
Okay, ma'am.
Yeah. And then similarly, if you want to, similarly, you what you have to do, you have to, I want you guys, please, next class, you install this QGIS software, okay, and you add all this URL so that if you want to work over any raster or vector data model, you'll be able to locate the feature but I want to add few more things based upon the class lecture in my slide, and I will be going to add some more information with what I have told also in my slide. Video is already there. You please look into it, and slides will be speaking some more things. So I want to uh, like merge all to both of my slides. That two slides I showed you, so that will be a combined slide. I will keep in that website. Okay, so you'll be going to access that slide,
Okay, ma'am.
combined slide. So you do one thing, you go to this page, download your QGIS, install all this URL as I told you, XYZ data, right click XYZ tile from the browser option, go to new connection, give the name whatever satellite. See here, name is also mentioned. You need not to worry about name. Google Maps, Google Satellite Hybrid. These are the products, and these are the URLs. So give that URL, do OK. Do OK. You want to see the map? Go here in the tile, double click. See Google Map. If I click, see here how Google Map is started coming. See, and
Okay, ma'am.
layer I have imported, it is also showing. Similarly, for roadmap also. Sorry, for roadmap also, if you if I click on the roadmap, it is loading because it will be showing road number of roads. So let it load. So if you want to if you don't want to work on another layer, because see whatever is the first layer it will only show. If you want to off, you can off clicking on this option. See, if I off this Google Map, it will be showing Google Satellite. So like that you can move. If you on this, you'll be able to see what is the first layer is there now, that will only show mostly. But if you have any down or bottom transparent, or first layer as a transparent boundary, you'll be able to see the bottom features also. But you have to on and off the layers, that is the thing. Okay, if I'm off, keeping off this layer, I huh, you want to see the layer now. See, Google roads are not appearing. Maybe it will take time, because roads na, see here it is loading. It's not like it is not there. Sometimes it won't appear because of, it will take more time. Okay, I am selecting Google Satellite Hybrid. No, Open Street Map I am selecting. So see here, Open Street Map, how it will appear. If I zoom, as we used to see in Google Maps, like that only. See here, like that we can see this maps. And if I want to, if I want to, I don't want what I scroll, it got more and more zoom. Or else I can scroll, or else what I do, I will select this, I will select this layer, I will do zoom, right click over that, zoom to layer. If you do zoom to layer, it will show this whole map. Okay, if you don't want to see this layer, if you want to see this Google Satellite image, off, this tick option is there na, just unselect this, it will show you the bottom layer. So like that you can look into these things. Now I did not told about rasterization and vectorization. Time went. Okay, let me just quickly tell about this how to add. Okay, I already downloaded. I will tell you from DivaGIS how to download. I'm just giving some hands on in each of my class, so that if you guys are interested, you yourself work how openly. I'm not keeping my thing downloaded or this thing. I'm downloading in front of you, and I'm working, because you also able to download, and you also able to work on your own interest area. How to download, how to get the tiles as a raster I showed you last class in Bhuvan, and today I'm going to show you for India shape file how you are able to download. Okay,
Okay,
I
ma'am.
already have this file, but I'm showing you how to download. So go to
Yeah.
Diva GIS, download the data by country. Okay, let me open.
Okay, ma'am.
Yeah, yeah. It will take some time because of my internet or something, I guess. Yeah. Is there any question? Sorry guys, I'm not asking this. Is there any question you can ask
Uh,
in between? You can stop me. Yeah.
No, ma'am. No, no more. No any question. Today's class was very perfect and easy to understand all things, especially how to use QGIS because I am very new in on this QGIS. So it is too good, ma'am. I have no
Uh,
questions.
it is loading, but I don't know what is the issue with my internet or something. Yeah, it loaded. So you have to go to that Diva GIS. Diva GIS is one platform which will be going giving you, see here, Afghanistan. So download data by country. We can download few shape files or data, road features. See what are the data available. See this platform. You go. I'm in India, so I'm going to deal with Indian region, country, and which feature. See here, administrative area means your states, your district. These things will be covering. Inland water like river basin, like Ganga, Brahmaputra. These things are covering. Roads, main roads, NH, national highway, state highways, these things, main road, village road, these things, minor roads will be covering. Railroads, paths. Elevation map means digital elevation model, also it is having. Land cover maps also it is covering. Population map. Okay, population map and population, these things it is. So what I will do, I want administrative areas. Administrative area, I want to locate India first. So what I do, I will select administrative area of country India. I will do OK. So it will give you, see here, how it will be going to give you downloaded file. Then how you will import this file in your QGIS. I'm just going to tell until here. So it showed, see here, country India, subject what I got, administrative area. So we have to download this. Then you click on download. See India shape file. See zip file. Here it got downloaded. I'll be going to open my file, download option. Okay, it's still downloading. Okay, wait. Yeah, it's still downloading. Let it complete. And then this all things, if you go and download zip file, raster file or vector file, everything from open source data you'll be going to get in zip format, because each file having some supportive file. Every information is not in one file. Number of ancillary or supporting file is also there to bring those things into your QGIS. That's why you will be going to get in a zip format. See, I got this file now. I am keeping my whole data in one file. That's why I am copying and pasting this. Okay, I got this. Let it complete. As I have started class a bit 5-10 minutes delay, that's why I'm taking some extra time, 5-10 more minutes.
No, ma'am. It's not a issue, ma'am.
Yeah, yeah, okay. Thank you. Yeah, it got done. So what I do, I will extract it. Extract file here. Okay. So I extracted, it came this file. See here, what are the things they have given from that open source. I got this India administration 1 2 with all. See here, as I told you, vector data is in shape file. As I have the software, so it is showing shape files, SHP, shape sources. But two more things, three more things are also there. That is AutoCAD shape file, that is projection file, that is database file, and one more comma separated files are also there. Whatever I want to but I want a vector layer. That's why I'm going with shape file feature. So what I will do, I will quickly import one of the file and I will show you how to import one vector layer into your QGIS. So I feel maybe from my class, you guys may be getting some extra information for the class. So okay, you work upon this. You will be liking to play with the software. Okay. So
Yeah, ma'am.
vector data I want to import. So what I do, I went to where I want. I went to QGIS Open Data Source Manager, and then vector I selected because I have vector data. I will allocate this browser where India. I went to my database, Indian administration. So see, I have India administration 0, 1, 2, 3. Let me show you what are the things this 4 file is covering. I am only importing shapefile. See here, shape sources. That is shapefile. Only because I want to work upon vector data. That's why I'm taking all other files are also there, but that are only supporting file. We are able to work on these files, only shapefile. I okay, one by one I'm selecting, or else you guys may got confused. Okay, let me select one, India administration. So what I did, I selected this file. Okay, wait. And I do open, and here see here add option activated. I do add and I close it. See what it came. Administration means all district boundary. See here. Now similarly what I'm going to do, going to same new data open source manager, click on the shapefile. Firstly I have imported the third one. Now I'm going to import this second one, India administration. Open, add, close. See on the same layer what I did, see the third one got hidden. It's not hidden, it's already there. If I uncheck this, you'll be able to see the administration district wise. Sorry, that is block wise, I say, because that is block wise. If you go to second one, you'll be going to see in district wise. In each district there are 7 8 blocks, and then it is giving this much detailed information. I will show you the attribute table also with this vector data. And again now I'm importing, this is second one. I want to import this first India administration first one. So go to that open data source manager, select your file location, click on add, close it. See here state map came. And then now what I'm going to do, again I'm going to new data source manager, vector file, and then I'm allocating this zeroth, because 4 things are there. So see, when I click on that India administration 0, open, add, close, see, this is the, so are you able to see, this is the India map shapefile, this is the state of India map shapefile, this is the district wise map shapefile, and this is the block wise shapefile. And now this is the Google satellite imagery. And I have OpenStreetMap also. So if you see,
Yeah, ma'am.
so these things you'll be able to understand. So okay, I am interested in state level, so I am only taking state level file. I on this state level file. See, if you on this OpenStreetMap or Google satellite, because it is covering whole globe, so it will take lot of time to load. Sometimes you may be thinking, "Arey, my data went somewhere." So better you do one thing: click on your layer, right click over that, zoom to layer. So it is like, it will show you the present your file where you want to work, which layer you want to work upon. Select that layer, right click over that, zoom to layer. So you'll be able to.
Okay.
Okay, fine. For today's class, I feel this much is enough. And I just want to tell you, go through these things, explore this platform, explore the open source data also, what in last class I have covered. Go to
Sure, ma'am.
for, see, this is the vector data we are having. If you right click, as I have went to zoom to layer, similarly if you come at bottom, you see here open attribute table option is there. Click on
Okay.
that, you'll be able to see what I have told in my first class: vector data having ID number, name, name of that state. I'm dealing with the state wise. If you see India level also, it will show you one. See here 36 Indian Union Territory. They have, see here it is mentioned Union Territory, states,
Yes, ma'am.
everything they have mentioned, which type it is coming, and null name is not there. And with what are the district? See, I have selected state level wise. That's why it is showing state level information. If I go to administration, third one means it is block level. I will go. I will select open attribute table. See how much information you are going to get from this. Like that you'll be able to see on the attribute table. And more what you do, go through this diva gis. If you're interested in elevation map, if you're interested in inland water boundary, you're interested in land use land cover, go select these things. Okay, download it, bring it to your qgis, see the things, you'll
Sure,
be
ma'am.
able to look into this thing. Okay, thank you class.
Ma'am, can I
Yes.
ask something, ma'am?
Hello?
Yeah, ma'am. Can I ask a question, ma'am?
Sure, sure.
Ma'am, if I want to work with my personal file, ma'am, is a zip file, ma'am, of my study area.
Yeah.
So it is the same process uh, to uh,
Bring,
I
yeah?
mean, yeah, ma'am. It is the same process to uh, come with the file of my oven area on this QGIS, ma'am.
Yeah, yeah. You have to go through. See here. If you have any file, if you don't know which file, like as you told zip file. So what you do, go to browser
Okay, ma'am.
where you have kept that area or region. Go to that file from here. See here. If I am going my C drive, so C drive, D drive, E drive, wherever you have kept, open that file from where, and you can bring it. You select, double click. See, when you go to it, it will support now. You have to that thing should be supported. When you go click, it will support. It will ask you to add, like as I showed you in vector how
Okay,
we
ma'am.
got add. So you'll be able to bring that file here. So like this is the procedure to bringing any file, whatever
Oh,
the things QGIS is supporting. Go to open data source manager, whatever the file. If you don't know shape file, raster file, TIFF file, JPG file, better you go to browser, select that file, bring it here, then you see all the information. Okay. Next class, I
okay.
will tell you about some coordinate system, and I will tell you about maybe projection if sir is reaching there. Based upon that, or else there is few more things are still there in this vector data attributes and raster data information. I want to tell you. Then one file I want to convert from vector to raster or raster to vector. I
Okay,
will
ma'am.
do this hands on in QGIS itself, so you'll be able to understand what is the procedure. Okay.
Sure, ma'am.
Today.
Okay, ma'am.
Okay.
Thank you, ma'am. Thank you very much, ma'am.
Yeah, yeah. Thank you so much.
Most welcome, ma'am.
Okay. Bye bye.
Bye, ma'am.